Okay, so implicit differentiation. Let's see if I can do. Yeah, it went right. So just 1 second while I restart this. And here we go. For problems 1 to 3, find y prime by solving the equation for y and differentiating directly. Find y prime by implicit differentiation, and then check that those derivatives are the same. So, yes, explicit versus implicit differentiation. Here we go. Making y the subject. Y cubed over x equals 1 over... well, I suppose it would just equal 1. And so y cubed, rather, y cubed would equal x, and so y equals the cube root of x, doesn't it? So dy by dx, well, that would be x to the 1/3. So that would be a third of x to the minus 2/3, which would look like 1 over 3 times the cube root of x squared, just like that. So that's explicit differentiation. And now let's try implicit differentiation. So it's totally valid for me to just say that that's... Well, I guess I could do the quotient rule, couldn't I? Yes, I could. I could do the quotient rule. And I think... Should I? Well, I've already got a product at this point. So I'll do the quotient rule when I really need it. Okay, so applying the product rule, applying implicit differentiation to the product rule. Let's do that. Okay. Differentiate the first one, leave the second one alone. Plus, differentiate the second one, leave the first one alone. So we get x like that. And then, well, I guess it would be like that, wouldn't it? That's equal to 1. And let's see here. Well, this is quite a mess, isn't it? All right. So minus 3 xy to the minus 4 y prime equals 1 minus y to the minus 3. And then divide through by all of that. So y prime equals 1 minus y to the minus 3 all over negative 3xy to the negative 4. Seems totally absurd. Really, it does. Anyway, I mean, Are these the same? Well, they could be with some more manipulation, but looks like we really have to get used to whatever this technique is. Okay, so that's straightforward and that was done correctly. And now just start the solution for this one. Okay, so they agree with us about, regarding that. Of course, you differentiate both sides, don't you? So that would actually... Okay, so we'll continue. So perhaps it could look a little bit like it. And then we'll have this here, and it's not so bad anymore. And so y prime would equal... Okay, these... And then we have y to the minus 3 over y to the negative 4. So that just has to turn into a single y right there, just like that, over 3, well, 3x, that would be. And then I could replace this y on the top with the cube root of x, couldn't I? So y prime is equal to cube root of x over 3x, which is x to the 1/3 over x to the 1, so x to the negative 2/3. That would be a third of x to the negative 2/3, and so they do match in the end. But let's see if okay, so we get this y over 3x, and part C we are to check if these are actually the same or not. All right, so there's the sort of final answer using implicit differentiation. It does mention a y and an x. And for explicit differentiation, for me to see that they're the same, I do actually have to solve y for x, as in make y a subject purely of x. So next, we try with problem 2. First, via explicit differentiation. So we say that y cubed is equal to 4 minus x squared. And so y is equal to 4 minus x squared all to the 1/3. And then finding dy by dx. To do that, we would do the chain rule. So this is a third of 4 minus x squared to the negative 2/3 multiplied by the derivative of the function on the inside, which is negative 2x. Just there like that. And that could be, you view it. So we could say that this is negative 2x on 3 on the denominator the cube root of 4 minus x squared all squared down there on the denominator. And that's just another way of phrasing it, so to speak. Now for implicit differentiation. as in differentiating with respect to x over each term throughout. So we get 2x from the first one plus 3y squared y prime equals 0. And then making y prime the subject, y prime would equal negative 2x over 3y squared. But we must make sure that this is the same as the answer from part A. And so to do that, we can clearly see that it's just this y here that needs to be checked. So an expression for y right there. So we could just say, using equation 1 from part A, we see that y prime is equal to negative 2x all over 3 times the cube root of 4 minus x squared all squared. And so they are the same. As we intended to show. All right, so it's going to take forever to load the solutions, if it does. So I'll load up multiple at once, just in case. Yeah, I'll load up down to 7, and we'll check them. All right, so we are in agreement about this dy by dx result here. Yeah, that's all fine. And here we agree. And here, yes, we agree. Next up for problem 3. Okay, so first differentiating directly or explicitly. Well, this is a circle, we should say as well. X squared add y squared equals 2. There's a circle. Whereas the previous one, x squared add y cubed equals 4. I don't know what that is yet, but I vaguely recall something like elliptic curves, elliptic functions, something like that. In time, I'll learn about these more, of course. But this right here, I know that this is a circle centered at the origin with a radius of 2. Radius of root 2, rather. So first, we make y the subject. So y would equal to the square root of 2 minus x squared. In other words, 2 minus x squared all to the 1/2. Then dy by dx, applying the chain rule, would be 1/2 of 2 minus x squared to the minus half, all multiplied by negative 2x. Now, 1/2 times negative 2x is negative x. So that would just become negative x. And then we obtain that. And now to differentiate implicitly. So we get 2x plus 2y times y prime equals 0. And then to make y prime the subject, so 2y prime equals negative 2x. So y prime equals negative 2x over 2y. So y prime equals negative x over y. Just there like that. And for part C, we must replace y with what we found in part A, an expression for y. So y prime is equal to negative x all over root 2 take x squared, just like that. So part A is indeed equal to part B, and we check everything. All right, so here we have a plus or minus. Okay, so I need to know that, and I need to be explicit with myself about that. That is a real plus or minus there, and it has to be, it's not just simply the same. All right. Okay. Right. Okay, you cannot just, need to be really careful here. So y is plus or minus the square root of 2 minus x squared. And the reason why we have to be really explicit about that is because we don't know if y is positive or negative. We actually don't know that. That's true. And therefore, if it's positive and we do the derivative of that, we will get the minus sign in the front. That's for y greater than 0. But for y less than 0, it would be that, wouldn't it? And therefore, this is not actually right. You see? So a lot more care has to be taken there. Okay, for this part here, well, we got this plus or minus business down here, don't we? Right, okay. Okay. All right. For problems 4 to 9, find y prime by implicit differentiation. Okay. QY. So, all right. Get that. I get 6y squared y prime. That, I just get 8x. that minus 1 times y prime, so minus y prime, and x to the 6. I'll get 6x to the 5. Then we need to make y prime the subject, right? So I'm going to have y prime multiplied by 6y squared minus 1. And we'll move that 8x to the other side to get that. And so y prime would equal 6x to the 5 minus 8x like that. So I believe. And we could factor out 2x on the numerator if we so wished, but there's no real need to do that. But let's see. Okay, that's correct. That's good. Okay, problem 5. 7y squared plus sine of 3x equals 12 minus y to the 4. 14y prime. That will become 3 cosine of 3x. Constant just disappears. We get negative 4y cubed y prime, just like that. Okay, 14y prime plus 4y cubed y prime equals negative 3 cosine of 3x. I can factor out y prime to get 14y add 4y cubed. And I could actually just make that the denominator straight away. If I sort of do it like this. And we'll get that. Okay, that's correct and that's good. Problem 6. That'll just be e to the x. Sine differentiates to cosine, so that'll be minus cosine y prime. So minus y prime cosine y equals 1. Okay, so 1 minus e to the x. So e to the x minus 1. All over cosine y. Just there like that. Okay, fancy. If they like. All right, problem 7. Okay, so this is a product. So product rule. So we have 8x times y to the 7 plus that'll be 7y to the 6, but then the 7 gets multiplied by the 4, so we get 28 y to the 6. The x squared is untouched. The y prime is there. Then minus 2, and that's equal to 5x to the 4. And this becomes 12y squared, y prime. Then we gather everything. We gather that's all there on the left. And that's all there on the right. And now in one step, y prime should equal everything that's there on the right divided by the result of factoring out y prime from the left. So it'll be 28 x squared y to the 6. That looks a little bit dangerously close to a 7, doesn't it? And that looks like a 1. So maybe like that. So minus 12y squared. Okay, so that's what I think it is. And we check. And that's nearly correct. How did I sort of mess this up? Okay. Let's think. Oh no, look. That's the negative of what it should be. And so must the numerator be. And it is. And so it's all good. Okay, now problem 8. Problem 8 here. Cosine of x squared at 2y, all plus x times e to the y squared equals 1. Cosine goes to minus sign, and this is the chain rule. So it'll be minus sign of what's inside the brackets multiplied by the derivative of what's inside the brackets, which would be 2x plus, and that would turn into 2, but then we have to multiply it by y prime, so 2y prime. And then we have a product. So first, differentiate the first function, leave the second one alone. So e to the y squared. And then differentiate the second function and leave the first one alone. So x, what's the derivative of this? Well, this is also a chain, isn't it? It's essentially this. And so by the chain rule, first differentiate the outside one. And then times it by the derivative of the inside one. So it'd be like that. Or so I believe. So let's just be totally clear here. All right, so it's getting quite involved here. I feel like I'm going to drop. So we're going to say 2xy, y prime, y squared, just like that. And that looks good. And now we need to get y prime by itself. Okay, so that is going to be on the left. And that will be on the right. And that will be on the right. And that will be on the left. And they're equal. Okay, so y prime, extracting that out. So I'm going to have minus 2 times the sine of x squared or 2y. And I'm going to add it to 2xy times e to the y squared. And then that will be equal to 2x sine of x squared at 2y minus e to the y squared. And then I'm going to divide through by all of that. So I'm just going to move that over right now. Just there like that. So I think that's the answer. Or so I believe. Okay, we agree there, and there, and there. That's good. Okay, he acknowledges that it's kind of messy, the algebra. That's correct. So is that. And that's all good. All right. Cool. Okay, problem 9. Problem 9. Tan of x squared y to the 4 equals 3x plus y squared. Okay, what's d by dx of tan x is sec squared x So, chain rule. There. And then we go inside. And we have a product to deal with. First function plus, and now second function. Just like that. And set that equal to 3. Like that. Whoops. Okay, factor out y prime. And set it equal to all of that. I don't know why it misses out pieces. Because I'm not casting the net wide enough. That's more like it. And then move that down there on the denominator. And everything looks good. Now we check. Okay, that's good. And the denominator? Is the denominator any good? Darn it. What's going on here then? What did I not do? No, that should be there. Why actually isn't that there? Oh my goodness me. I can actually... Right, okay. Do over. Right, how can we do this? Because this is so much excess, isn't it? Goodness me. Well, at least put it at the front. 4x squared y cubed y prime sec squared x just like that. And now carefully move everything around. So that there, see, it just doesn't capture everything. That there will go to the right, and so it will become minus. That there will go to the left, and so it will become minus. So minus sign. Minus sign. Move it carefully. Just there like that. Bring that y prime outside. 4x squared y cubed 6 squared x squared y to the 4 minus 2y, and leaves the right side just as it is. And then bring that under, just there like that. So we need to bring that over. And now check. Okay, that's great. Fixed. For problems 10 and 11, find the equation of the tangent line at the given point. X to the 4 plus y squared equals 3. I'm kind of curious what that graph looks like. Because something I know, well, this is, I know that x squared plus y squared equals a constant. That's a circle, e.g. that. And if I make these powers even, I'll get a more squarish circle like that. Oh, and the radius is smaller, I guess. But what happens when they don't match? Oh, that's cool. Okay, I'll make that 14 and like 8. Oh, this is cool. I can make kind of like pseudo rectangles. All right. Problem 10. First, I will substitute these coordinates. No, wait. Do I want to do that? No, I don't. Instead, I'll just straight up differentiate. So I'll get 4x cubed plus 2y y prime equals 0. So y prime is equal to minus 4x cubed over 2y. Now we'll sub these points. So y prime is equal to negative 4 over 2 times negative root 2 4 over 2 root 2 is 2 over root 2, which is root 2. So now we use y minus y1 equals mx minus x1. And we'll say y plus root 2 is equal to root 2 times x minus 1. And so y is root 2 times x. We have to take root 2 and then take another root 2. So perhaps it's something like that. Okay, that's great. That's true. Problem 11 will be the same sort of thing, but harder, I suppose. Okay, we have a product on the left, so we'll differentiate that. 2yy prime e to the 2x plus 2y squared e to the 2x. And that equals 3y prime plus 2x. So, what does that mean? Y prime 2y e to the 2x minus 3 on the left minus 2y squared e to the 2x plus 2x on the right. Make it the denominator. Bring everything over. Like that. And sub 0, 3. So y prime equals negative 18 that will be e to the 0, which is just 1, plus 2 times 0, which is nothing. This will be 6. 6 minus 3 is 3. So we have minus 6. Then y minus y1 equals m times x minus x1. So y minus 3 equals minus 6 times 0. No, x minus 0. So just x. So y is equal to negative 6 plus 3. Well, so I believe. And that's right. That's great. For problems 12 and 13, assume that x is equal to x of t and y is equal to y of t, and z is equal to z of t. Then differentiate the given equation with respect to t. Okay. Is it just going to be 2x x prime? Or maybe they want me to say dx by dt. Whatever. I'll do both. Dx by dt minus 3y squared dy by dt plus 4z cubed dz by dt equals 0, something like that. Okay. $13. Okay, so we have a product, and it's of two functions. All right, so let's think. Differentiate the first one, and we get 2x x prime cosine of y. Differentiate the second one, and we get minus x squared sine of y times y prime. And then on the right-hand side, we have a chain. So there's the outside one. And multiply by the derivative of the inside one. So we get 3y squared y prime plus 4z prime. No, can't fit it. What if I do this? Hooray! It's on one line. Okay. And that's correct. And that's good. Right, okay, I'm going to brush my teeth. All right. Now, implicit differentiation. Okay, so now these wordy word problems, which I find difficult because I'm more inclined towards just computation. Nonetheless, try your best. In the following of t, given that x equals -2, y equals 1, and x prime equals -4, determine y prime for the following equation. So I suppose I have to differentiate first. Why do I have to assume that they're functions of t, though? Well, let's just go ahead with it. So 12y y prime plus 2x x prime equals, the constant will disappear, and then we have a product. So differentiate the first function. So -3x squared x prime times e to the 4 minus 4y. And then differentiate the second function. So if I do that, I will get negative 4 times e to the 4 minus 4y, -4y prime. So it becomes plus. Like that. Okay, and so somehow this is supposed to help me get what y prime is. All right, so I'll move everything involving y prime over to the left. So 12y y prime minus 4x cubed y prime e to the 4 minus 4y, and that's equal to that minus that. And then I'll factor out y prime and get 12y minus 4x cubed e to the 4 minus 4y. And all of that is divided by that. Now, I guess we just sub. So y prime, let's see, squaring that, we get 4, so it would be minus 12. And then we have to multiply that by negative 4, so 48. To the 4 minus 4, so that would be 0, so 1. So that just disappears entirely. Then minus 2 times minus 2 times minus 4 would result in minus 16. And we'll have 12 down here. The cube of negative 2 is negative 8, so it becomes 32. And that is established as 1. So that would be 32 over 44, which is 16 over 22, which is 8 over 11. Or so I think. We're about to see. Oh, yay. That's actually right. Okay, so it's not so bad. Okay, so then more or less the same thing, isn't it? Or so I think. We have to determine z prime. So what am I going to do? I'm going to first multiply that out. Not for any particular reason, I just really don't want to be tricked by a bracket. Okay, now differentiate. Okay, so just x prime. Then we have a product here. So differentiate the first factor. Leave the second one alone. And differentiate the second factor. Leave the first one alone. Plus 15z squared z prime equals, and then we have another product. So, okay, let's see if my mind can actually handle this. When an equation is on 2 lines, or do I need everything to be on 1 line? No, I'm not ready for it. Don't push me to the extreme. Okay, so 2y y prime z squared plus 2z z prime y squared plus superfluous brackets plus 2x, x prime, and then the constant disappears. So there. Now, get rid of that bracket, so minus sign right there. And now we want z prime by itself. So that one. And that one. Just there like that. Everything else on the other side. Okay, so 15 z squared z prime minus 2z z prime y squared. And what we can do now is factor out that z prime straight away. Wait, is this like a... Oh no, it stretches it and all that stuff. Minus 2zy squared, alright. I'm going to eliminate that. Move that over a little bit. Okay, that's great. Now, everything else on the other side. So, first, the things that are already on the right-hand side. So 2yy prime z squared plus 2xx prime. Then these three guys. So minus x prime plus x prime y plus xy prime. And now divide through by that. There. Oh, that's cool. So, picking up my numbers, z prime will be 2 times negative 2 times negative 3 times 1 squared, so just 1, plus 2 times 4 times 9 minus 9 plus 9 times negative 2 plus 4 times negative 3. And then all of that must be divided by 15 times the square of 1, so just 15, minus 2 times 1 times the square of negative 2, so 4. All right, now we have to sort this out. So we have minus 12 right there. 72 right there, minus 9, minus 18, minus 12, and all of that has to be divided by 15 minus 8, which is 7, and continue. That makes 60, and 60 minus 9 is 51, and 51 minus 30 is 21, so 21 over 7, which is 3. That's what I think. I think the answer is 3. Nope, totally wrong. How? Luckily, I have all my steps. Okay, we agree about that. And that. And that. And that. And that. Okay. Total agreement at that point right there. But it appears that this step was just totally unnecessary. It's something which introduces error. Right? Well, if it's unnecessary, it's unnecessary. I'll just have to delete the whole thing. Okay. I'll try again. Here. So I'll have 9 minus 9 times negative 2, which is 18. That's going to be 18 with the minus sign in front of it. And then 4 times 9, so minus 36. 15z squared, that's just 15. 15z prime. And that's equal to negative 4 times negative 3, which is 12. So just 12 there. Plus, what's 2zy squared? 2 times 4, so 8. And then here, 2 times 4 times 9, which is 72. And check it out. I'm missing z prime. There. 9 plus 18 minus 36. Well, that would be 27 minus 36, which is minus 9. Twelve at 72 is 84. So 8z plus 84. So 7z on the left. And 84 plus 9, which is 93. So I know that that's not right, because I saw it. So what is it that I'm not getting correct here? Probably this. Two times 4 times 9. No, that's fine. We agree on the right-hand side. And on the left, right, that's where there's disagreement. 27 at 12. Somehow. There's their 27. Why is this 12? So negative 4 times negative 3. Of course it's 12. It's plus 12. So why isn't this computing then? $39. So 45. Right? Good. Okay. Corrected. For a certain rectangle, the length of one side is always 3 times the length of the other side. If the shorter side is decreasing at a rate of 2 inches per minute, at what rate is the longer side decreasing? What? This seems way too straightforward. Why is it not just 2/3? Uh-oh. I better check. The shorter side, after 1 minute, has become 8 inches. And, oh no. How foolish. There. Well, at least I found it by checking, right? Okay. Don't think you need to do that. Anyway, at what rate is the enclosed area decreasing when the shorter side is 6 inches long and is decreasing at a rate of 2 inches per minute? All right, let's say, let's just think about what we know. X but that's simply 3x, isn't it? And dx by dt. No. Maybe I should have another variable here. I actually will do that for once. I'll call it y. And I'll just declare that y is always equal to 3x. Now, dx by dt, we're told, is -2. And we're given the initial condition that x is 6. And we are asked, what are we being asked? We're being asked this, xy, d by dt of that. That's what it's asking us to do, right? Okay, so first of all, notice that everything could really just be using the prime stuff that I know and I'm comfortable with. And what is x, the prime of xy? It would be x prime y plus xy prime, wouldn't it? Right? And if x is 6, we immediately infer that y is 18. And so what? Oh, then the only thing we need to find out is what y prime is. Okay, well, if y is equal to 3x, then dy by dt would be Am I not thinking through this straight or what? No, I mean, I just did it, didn't I? That's decreasing at a rate of 2 inches per minute. So the longer side must be decreasing at a rate of -6 inches per minute. It's as simple as that. There. So that has to be, when I plug everything in, -2 times 18 plus 6 times -6. And that's -72. So -72 square inches per minute. We can say that, right? But we must check. Well, it's here. Okay, so they agree with me. And that's great. 4. A thin sheet of ice is in the form of a circle if the ice is melting in such a way that the area of the sheet is decreasing at a rate of 0.5 meters squared per second. At what rate is the radius decreasing when the area of the sheet is 12 meters squared? All right, so fact. That one. And what is dA by dt? That'll be 2 pi r times dr by dt, or so I believe. Okay, and we are told dA by dt is this. And we want to know, and we're told also that A is 12. And what we want to know is what is dr by dt, right? Am I right or am I wrong? I think so. So if A is 12, then R is 12 over pi, the square root of 12 over pi. Now, this, right, let's just establish what's actually the case. dr by dt should be dA by dt divided by 2 pi r. And so just putting everything in, we're going to have this divided by 2 times pi times this. Or so I believe. And so we've got to compute that. So we're so I'll use this. And I get a very small number. Seems way too small for what's actually going on. But I'm curious. No, actually it works. Oh my goodness me. Okay, I'm very happy about that. Problem 5. A person is standing 350 feet away from a model rocket that is fired straight up into the air at a rate of 15 feet per second. At what rate is the distance between the person and the rocket increasing? At 20 seconds after liftoff and 1 minute after liftoff. So, mental picture. Person, rocket, and we have that, and well, like that. Okay, and we also have that, don't we? Yeah, we do. Okay, so at first, they are 350 feet away from it. And it's fired up at a rate of 15 feet per second. Yeah. And then we have this distance here to think about. And of course, it has a symbol D, which is of no service to anyone. So I'm just going to use S for displacement, something like that. And what do I want to think about? Okay, so what's the relationship here? The relationship is that S squared will be 350 squared plus 15 times however much time it's been traveling in the air, and all of that squared, and that's true. And what else? Well, that's it, isn't it? And what we want to know is we want to know ds by dt, right? Okay, so we're going to do this. Okay, that's just a number, isn't it? So we'll end up computing this, and then we'll know that t equals 20 for part A. And S is the very thing that we want to know. So let's get to it. $450T. And so what do we do then? just literally substitute in 20. That's it. Seems a little bit too straightforward for this, but we'll see. And what we obtain is 9 point this and here t would just be 60. So that should be a different number. Okay, that's correct. That's great. That's also great. Now, a plane is 750 meters in the air, flying parallel to the ground at a speed of 100 meters per second, and is initially 2.5 kilometers away from a radar station. At what rate is the distance between the plane and the radar station changing? Initially, and 30 seconds after it passes over the radar station. All right, and we have a nice diagram here. Pretty much just the same thing. Okay, then. First, just establish that S will be the square root of this much squared plus, now be careful here because it's actually going to be 2,500 minus 100 times however many seconds have passed squared, just like that. And so ds by dt, in other words the velocity, will be a half of this to the minus half multiplied by the derivative of this. So that, when I expand it out, 2,500 squared minus 200t plus 10,000t squared. And I differentiate that, and I'll get minus 200 plus 20,000t. So I'll bring that up here. And now for part A, when things are initially so, right, so ds by dt is like the question mark. That's what we don't know, but we know that t is equal to 0. So we just substitute in 0, and we'll calculate that. That squared plus that squared all to the negative half, and then multiplied by that. And we get something totally ridiculous. I mean, that is just totally ridiculous. But you never know. I mean, you do know. So I don't know why I'm saying that. So what we're going to do is replace that with 30 now. Minus 100 times 30. How can that be? Right, so the first clue that this is just total nonsense is that it's negative. Then what did I do wrong? Very quickly glance, just see if glance. Okay, we get a negative number there, and we get a positive number there. Okay, so I'm wrong. Oh, where did I go wrong? That distance there squared plus that distance there squared, square rooted, and we get that distance there, of course. So what is that distance there? Well, let's think. It's 2,500 meters away minus 100 for every single second. And then what we did is we just differentiated it. So a half goes in front, minus a half up there. The interior of the brackets don't change. And then we have to differentiate by the interior of the brackets. So constant disappears. Just care about differentiating that. So square it out and differentiate it. Why is that not valid? Excuse me. Why is that not valid? Don't know. Really can't see anything wrong with what I'm saying here. But, we have to check. Okay, we're going to do this thing where we just start the solution off. What? Okay, what I'm more concerned about is why is my reasoning wrong? But how? How is that wrong? You can do it this way, but I don't see the need to. But why is that? I have all the ingredients. Come on. Tell me why. Think, think, think. That matches that exactly, and it's square rooted 1 over the square root of it, 1 over 2 times the square root of it, in fact. And this obviously doesn't resemble it at all. So, okay, so it's on the denominator, which is what I want. But what's on the numerator is this. We've got the minus 200 there. But where does this 2,500 come from? That's what you should care about and be thinking about. Okay, let's go by their thinking. We have x here. We don't know what x is. And z. And z squared is equal to x squared plus 750 squared. Agreed. Differentiate with respect to t. So 2z z prime equals 2x x prime. So we get that. All right then, I'll just have to do it your way because I can't actually figure out why my way is wrong. All right, so let me think. How did they do it? Then differentiate with respect to time, which is t. This thing squared, which is that, then z prime, which is indeed what they care about. This, is it not? And we want z prime. For part A, we say x equals 2,500. X prime negative 100. Wait. Is this where I'm thinking? Is this where my thinking is wrong? It's something to do with the fact that the plane is moving parallel. I feel like it's something to do with that, but I can't quite articulate it. So we know that x is equal to this, x prime is equal to this, and z is equal to what? What? Well, it's equal to that, isn't it? Square root of 2,500 squared plus 750 squared, whatever that happens to be. And so z prime should be two times this. times this plus okay, I'm beginning ever so slightly to lose my patience with this problem. Because that's not right. So what's wrong? No, that should be twice as large, but that would make it even worse, actually. Wouldn't it? Okay. Am I absolutely losing my marbles? That should be a negative sign, don't you know? No, it shouldn't. You don't know what you're talking about. All right. Check. Okay, at least that's right. 2zz prime. Oh my goodness. I'm embarrassed. There. Now. Let's see what happens when I fix this. Well, the 2's just lost off. So that there should disappear because I have a 2 there. And we actually have something that's right, which is great. Negative 95.78. Okay, so I'm very happy about that. Still do not know why I was wrong in the first place, not fully, but I think the best thing to do is now think about part B. So that should just simply be subbing in 30, wouldn't it? Would it not? Okay. All right. So yeah. $30 times 100, 3,000. So negative 500. But of course that will be squared out. And so I need to care about that. don't I? No, just think of it like this. X is now just negative 500. X prime will stay the same. Z, what is Z? That will be the square of negative 500 plus the square of 750. And so Z prime will be, think that times that over this. Whatever that happens to be. Okay, square root time. Okay, so it's a positive answer, which is positive. It's around 55. We glance, and it's wrong, and it's so frustrating that it's wrong. Why is that Z though? Well, can't you see that it's over there? So when you're doing this whole triangle business, okay, so if we just let's just say blindly use these numbers and don't try to make it make physical sense. Like yeah, I would just plug in 3000 right there and right there, and that would give me that number. But I do not understand why my reasoning is wrong. That and that is something I'm going to have to think about because it's really important. Probably this is like when it comes to reciprocals and stuff like that. It's just a case, I'm just waiting for it to click and I'll be like, oh yeah, of course it is. Okay, a whole lot of word problems. But I'm feeling mechanical. So I'll put a bookmark in this and I'll resume at some other time, but because now I want to do higher order derivatives. Yeah. So new. Determine the fourth derivative of the given function. Great. So I get to do my favorite, where I put an IV there like that. And I must differentiate things 4 times over. So I do it once. I get 21t to the 6. Twice. I get 126 t to the 5. Thrice. I get 630 t to the 4. 4 times. I get 2,520 to the 3. Next up, okay, once I get negative 24t cubed, negative 72t squared, negative 144t, negative 144. And that will disappear. All the rest will disappear. Let's see. Hooray. Okay, so they don't like to be all traditional and fancy. So I'll do a little 4 up there like that. And when you differentiate this 4 times over, it just becomes nothing. So I believe. But we must check. Yeah. Now for the third one, let's take care and actually differentiate step by step. So this is 4x to the 3/5. 4x to the 3/5. Then that's minus an eighth, x to the minus 2. So plus a quarter, x to the minus 3. And here, that's minus x to the half. So it'll be minus a half x to the minus half. Then do it again. Minus 24 over 25 x to the minus 7 over 5 minus 3/4 x to the minus 4 plus a quarter x to the minus 3 over 2 triple prime. Seven times 24 is 168, like the amount of hours in a week. 125 is just a glorious automorphic number or whatever. And here we have plus 3. And here minus 3 over 8. There. And now finally, so what's 12 times 168? $2016. Or so I believe. But we're about to be proven right/wrong/indeterminate. Oh, yay. Okay, that's correct. I love it. Fourth one. Sine and cosine. I call this the cosine clock. When you differentiate, it goes round like that. So let's do it. Let's differentiate. F prime of W. Well, that would be 7/3 cosine W over 3. And then this here would be sine goes to cosine, cosine goes to minus sine, but check it out. There's a minus sign right there. Sine with a G in it. So that's going to be plus. And again, whoops. Sine goes to cosine. And the cosine shall have a minus. And a third time, minus 7 over 27. And then a plus, right? Or wrong. Be careful, be careful. Okay. That goes to sine, but then that shall have a minus sign in front of it. Nearly there. Fourth derivative. Sorry, 7 over 81. And we are back. And we check. Oh, great. I love it. Fifth one. I'm not doing, well, no, I should do, for flexibility's sake. dy by dz. Never get too accustomed to some variables or notations or whatever. So let's see. Minus 5e to the minus 5z. And a chain. We have a chain here. d by dx of ln x is 1 over x. And so it's 1 over the function. No. d by dx of ln of f is f prime over ln f. No, is f prime over f, rather. Something like that. So, what's the prime of that? That would be 8z cubed. And there's already an 8 there. So, 64 z cubed over 2z to the 4. And that is just begging for simplification, isn't it? So 32 over z. How about that? Now d2y by dz squared. That will be 25 e to the minus 5z. That much I understand. And wait a minute. That's 32z to the minus 1, is it not? Yes, it is. So minus 32z to the minus 2. d3y by dz cubed. Minus 125 e to the minus 5z. Plus 64 z to the minus 3. d4y by dz to to the 4. 625 e to the minus 5z minus 192 z to the minus 4. I sure do hope this is right. And it is, and that's great. So, for the next few problems, determine the second derivative of the given function. Second derivative. So we're going to need g prime of x. And it's a chain. So cosine of that multiplied by that. Which is this, just for my own sake. Do that, otherwise I'll have a nightmare. No, wait. No, wait. This is a product. So, product rule. Yeah? G double prime of x, which is how far we're going to go. So, differentiate the first function and leave the second one alone. Minus sine of that. But then we have to differentiate the inside, because it's a chain, is it not? Okay. And then a plus sign, and then differentiate the second function and leave the first one alone. So we have 12x times this cosine right here. And so that there will be square. That there will be square. You there shall be square. There. I think that's right. But only time will tell, and only eyes will tell. Okay, that's right. So is that. Great. 7. Z equals the natural logarithm of 7 take x cubed. So the z by dx is minus 3x squared over 7 minus x cubed. And now quotient land. d2z by dx squared. F prime g minus fg prime all over g squared. So f prime. Cool. You know what? Maybe I should consider what higher order derivatives of the natural logarithm are. You know, because there's obviously a pattern here. Okay, so times everything out so it looks nice and pretty. Minus, 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 so minus. And 6x to the 4 minus 9x to the 4 is minus 3x to the 4, is it not? All right. Okay. So now we come to problem 8. Q prime V. First, let me just be clear. This is this. So, what is Q prime V? It is minus 8 times, beg your pardon here, there, times minus 2V plus 2. And now that you've established that, can you obtain Q double prime of V? All right, then I will. It's a product, so differentiate the can I just bring a minus 8 outside? Okay, we're going to do these fancy curly braces here. So differentiate the first one, leave the second one alone. So if I'm going to leave the second one alone, I'm going to put it right there at the front so I don't forget about it. Minus 2v plus 2, of course, that comes out, and so that is there is square. Okay, that does the first one. And now you must differentiate the second one and leave the first one alone. So that'll be minus 2. So that comes there, turns that into 16. But hold on just a minute now. We've got that minus 8 out there. So that'll be a minus 2 right there. And we already hate the minus 8 on the outside. So there, like that. So that's going to be a 40, and that's going to be a 16. And we're going to do that because it's all good. And we obtain this. We don't know if it's true. We're about to see if it's true. And it is true, and that's good. And now the 9th. So ht is cos squared of 7t. That's how I've heard some people say it. Cos squared of 7t is my usual way. So I always say to myself that it's actually this, and I need to be explicit. H prime of t, differentiate the outside and times by the derivative of the inside minus 7, excuse me, minus 7 sine 7t, like that. So minus 14 cosine of 7t, sine of 7t. Am I saying the number after 69, or am I saying 7t? Who knows? So h double prime of t. This is a product, so we do the product rule. So we differentiate the first one and leave the second one alone, and when we do that, we go so it becomes this. Doesn't it? And then you differentiate the second one and leave the first one alone. Sine goes to cosine, so this will be minus 98 cos 70, cos 70. You notice how gorgeous it looks. How irresistibly precise. Anyway, sine squared minus cosine squared, not an identity, but if we're dealing with hyperbolic trig functions, maybe. Anyway, let's get it. Hooray. Okay. Now, why are these cordoned off? Cordoned off. I don't really, I think it means sectioned off or something like that, but anyway. Because here is going to be implicit differentiation time. So, yeah, my question to you is, wait, excuse me, differentiate with respect to what? You never told me. And therefore, I am to assume it's in terms of a third variable, or am I? Okay, so I don't see an x prime, so I'm going to assume it's d by dx. So we're going to have 6x squared plus 2y y prime equals minus 4y prime. That's my first derivative. And I'm going to make it the subject. Wait. Did you even... Okay, you didn't think. So y prime, open brackets 2y at 4, equals minus 6x squared. So y prime is equal to a quotient. Fireworks now. What? Now y prime prime is equal to f prime g minus f g prime all over g squared. F prime g minus f g prime. Differentiate that, we get 2y prime, just 2y prime over the square of that, but probably they want it pretty. I think it looks fine, but you know, who knows what they want. So I'll say 12 x squared y prime why am I getting like this vision of this differential equation book I once saw? It's orange. I don't know. Then minus 24xy minus 12x. And all of that can be over the square of this. And we'll see, and we'll see, and we'll see how correct I can be. And he decided to do this. Not sure why. Oh, I get it. So that he could say that he did everything. Well, I'll have you know that that could be seen as correct by some people. Right. Okay, so did we agree up to this point at least? Oh, we did? Oh, that's great. And indeed, we could actually express it as that. And then at the very end, they express it as that. So I'm perfectly willing to try it. Cancelling out 2, we have minus 3x squared over y at 2. which is this. And we have 12 outside. Really? What? There's no way that's simple. Look, I'll bear it in mind next time, okay? I didn't know that you wanted it that way. First, implicitly differentiate. Six y prime minus y squared plus 2x y prime equals 0. And therefore, y prime 6 minus 2x y is equal to y squared. So y prime is equal to y squared over 6 minus 2xy. That's great. I love that. But we remember y squared 6 minus 2xy to the minus 1. And now we differentiate again. F prime g minus fg prime all over g squared. Six minus 2. No, that will actually be fine, thank you. Are you forgetting that this is a product? No, I'm not. Okay, so differentiate the first one. And then minus 2x. Yeah. And that y prime right there, well, that y prime right there, we're now going to replace it with the thing that he wants, which is like y squared and 6 minus 2xy to the minus 1, like that. And if he wants me to simplify that, he is a simpleton. But some of it surely can be simplified. Really, there's, we notice this and this. This cannot be not noticed. And then we notice that there's two. There's really two things there, isn't there? So there's really three things altogether. And if we glance and we see all steps, Yes, he does something like this. But look at that. Look at that. Look at that. Okay, so he does some simplifying here. Simplifying to him. Okay. Yeah, like that. Okay. So I'm going to do it in my own way. I'm going to do it like this. Just because I really like doing it like that. Because I think it's pretty. I think math should be pretty. If you can make it pretty. It's not always possible. But if it is possible, why not try? Yeah, you see? All these negative indices and all that business. Whereas my personal way, I think it looks nice. But anyway, who's next? Logarithmic. Oh my goodness. Oh man. Look at this. It's like they saved the worst till last, till the end of the chapter. So, well, I'm going to do it. But first, a bathroom break. Okay. So, what is logarithmic differentiation? First, I will save this. Next, start something new. And I'll try and remember. Okay, so I think if I remember, it's something to do with the way in which you differentiate this. Right? Because I know how to do d by dx of x to the n, and I know how to do d by dx of a to the n, of a to the x rather. That's what I get for that. And that's what I get for that. But I can't do it for this, right? So I think what I have to do is, if I remember, it's something like you take logs of both sides. And then that x can come down to the front. And then and then do you do it? I know that I could just implicitly differentiate at this point, but no, well, why didn't I do that then? Yeah, implicitly differentiate that, and we get y prime over y. And then for this, we'll get ln x plus that would be x over x. Yeah, so 1. So then y prime is equal to that. And so y prime is equal to this. Something like that. I remember something like that for logarithmic differentiation. But I have no... how is that going to help me here? How will it help me here? And furthermore, why would I even need it? That's a product, is it not? And it's not that bad. All right, I'm going to look at the notes and see the examples and see if I can jog my mind about how it actually works. But first, a jumper of some kind, as it's getting cold. I'll put this on. It's like Resident Evil. All right, so yes, that's what I did. Okay. I get it. Cool. Okay. Oh yeah, I mean I just did that one. Mm-hmm. 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 Gotcha. Okay. I'm ready. Don't need that. Yeah. Let's get started. Logarithmic differentiation. All right, let me try. Natural logs for both sides. I'm not going to write the big natural log of that. I'm just going to try and do the laws of logs in my mind. So log of a product is a sum of logs. Log of a power is a multiple. So 7 ln 5 takes 3x squared plus all of that is to the half. So that'll come there. Next, implicitly differentiate. I need to like sort of draw this into my mind. d by dx of f, d by dx of ln of f of x. So it's 1 over that, and then so it's going to be f prime x over f of x. Need to remember that. Okay, now for this lot here. So it really is just 7 times the derivative of the inside over the inside. So that's minus 6x. So that would be minus 42. There. And over here, derivative of the inside is going to be 12x at 8. So we're going to have 12x at 8 all over 2 times the inside, like that. And then you're on another planet if you think I'm going to write all of that out and then all of that out there. It's just ridiculous. So, you know, what I can do for you, though, is this. There. And make the substitution yourself, if need be. There's no simplification that will result. I don't think so. See? It's just all of that. It's not anyway, the important thing is this right? Well, it's kind of nearly right, but we could have cancelled that too. And it would have been more pretty. There. Okay. Next one. Okay. Ln of y equals ln of a quotient, which is the log of a quotient is a difference of logs. So it's that. Actually, I may have to pause here because my eyes are beginning to hurt, and that's no good for your health in the long run. Never compromise your eyes. All right, be well, be well.